proportional to the intensity, and phase, relative position of wave, which is lost, related to the peak position. And then we have structure factors, observed structure factor at scale. So structure factors are actually related with the intensity. So when we are measuring the intensity, we are measuring the structure factors. And then come to the structure factors of how to get an electron density map from reflection or diffraction intensities. Amplitude of scattered X-ray from each type of atom depend upon its electron density, described by atomic scattering factor F. So there are two things, small f and capital F. Small f is actually the scattering factor, and capital F is the structure factor defined for the whole molecule, and F is defined for a particular kind of atom. F is used to describe scattering vector for each atom for one reflection, which Miller indices H, K, and L. And then sum of scattering factors, scattering vector is molecular scattering factor F, also called structure factor, can be calculated by applying the Fourier transforms. Then come to the phase problem. In the course of the diffraction experiment, the X-ray photon, when passing through the crystal, interact with the electron of the atom in the crystal, giving rise to the diffraction pattern, which consists of the reflections. Each reflection corresponding to a structure factor F at scale, which can be understood as a Fourier summation over all the atoms in the unit cell. And the value of density rho at a given point x, y, z in the unit cell depends directly upon the measured intensity, and I is proportional to structure factor square. And this is the mathematical expression where structure factor capital F scale is the summation of all the atoms, scattering factor then exponential of 2 pi iota hx ky lz. X, y, z are coordinates and HKL are the Miller indices. And when reverse this Fourier transform, we are getting the back electron density. So electron density at any point x, y, z defined as the 1 by volume of unit cell, summation over all x, k, and l, structure factors and exponential of this term. So where is the phase now? Actually, the phase phi is hidden in the atomic coordinates x, y, and z, and here phase phi is equal to 2 pi hxi, kyi, and lzi. And this is actually the complete expression. Here there is square root of intensity because the Fs scale is approximately equal to square root of intensity, as intensity is proportional to the structure factor square. So here you can see this rho is actually electron density, and here is the intensity, and here is the phase. So we have two properties associated with the diffractive rays, the intensity and phase. This is missing information to get electron density. This is the missing information phase. So we need both intensity and phase. Without phase, we cannot determine the electron density. So we need both intensity and phase. Intensity we can measure using the detector, and phase we have to reconstruct using the different methods like direct methods, Peterson methods, and vector methods, and so on. And then solution of phase problem is by direct methods, which are most popular nowadays, developed mainly by the Hoofman and Corley in the 1970s. And then Peterson methods is mainly used when there is some heavy atoms are present in the structure. And then other methods are also available: molecule replacement, multiple isomorphous replacement, multi-wavelength anomalous dispersion, phase improvement, and so on. So what we have the F observes. So when we have the data, the F observed, the structure factor observed are stored in these two files, .ins file and .htl file. So these files has information of observed structure factors. Then what we do to solve it by solving the phase problem. We have to solve it. So after solution, we get some electron density maximas here. You can see. So some are looking dark. So these are heavy atoms. So we first find out these heavy atoms, and then we use the coordinate of these heavy atoms as input for the second step, and the input of the second step for the output of the second step as the input of the third step, and so on. So when we model, what we get some electron densities here, the blue color, shown in blue color. There's some more electron density are coming there. And then what we do, we calculate the structure factors. So we have the observed structure factors and we have the calculated structure factor. So we match these two structure factors. So there is a minimum difference between the F calculated and F observed. We will do the repeated refinement. This is known as refinement. So the matching of the F calculated with F observed is known as the refinement. We do this refinement over and again, so that we can get a good electron density map like this. So then now you can see the structure is appearing there. So F calculated is going close and close to the F observed, and so on. We finally get the structure, and we assign all the atoms, and we get the structures. When F calculated matches with the F observed, the refinement is over, and we get the final structure of our compound. And then come to the .ins file, the instruction file. This is some kind like this. So on the top there is title. You can see these are either 4-letter or fewer letter words. Title. Then you can take any name. So this is K2 in P21 by N. This is a space group. And then is number 14 in the standard setting. So there is some settings in international table of crystallography. And then cell. Cell first entry is the wavelength of the radiation you are using. So it's 0.71073. So it's molybdenum radiation. And then A, B, C, alpha, beta, and gamma, which and A is not equal to B, not equal to C. And alpha and gamma are 90 degree, and beta is greater than 90 degree, and that is corresponding to monoclinic crystal system. Then there are means some value of Z. Z means the number of formula units per unit cell. So the value is 4 here, and error means the standard deviation in the cell parameters. And then lattice is equal to 1. So for primitive lattice, it is defined as 1. For the body center, is 2. For the rhombohedral, it's 3. And for the face center, is 4. For A centering, 5, B centering, 6, and C centering is 7. And we made it negative when our space group is non-centrosymmetric. Otherwise, the value is become positive. Then symmetry, these are the coordinates of the general positions. SFSCs are scattering factors. These scattering factors present like carbon, hydrogen, nitrogen, oxygen, chlorine. And then units, how many carbons and hydrogen and so on are present in the unit cell. Then TAF is a command to solve the structure by direct methods. And then HKLF4 is the instruction to read the HKLF4 file. We have actually different kind of HKLF file. The common one is the HKLF4, although we have HKLF5 and HKLF6 also, but the most general one is the HKLF4, and then the instruction int, which end the instruction. So this is typical form of an .ins file, although there is more entry depending upon the situations. And then if you look at the other file, here the space group is C2 by C. So this is C centering, and this is permittive. So here you can see the lattice value is 7. Earlier it was 1. So for C centering, the value is 7. Then symmetry and same thing are there. Sometimes we cut off the data at 2 theta 52 degrees. And fmap is Fourier map. This is a default command. Fmap is always 2. And plan is the number of cubics you put in the difference Fourier map after each refinement. And then this is another form of the INS file in space group FDD2. So here you can see A, B, C, they are not equal to each other, but triangle are equal to each other. So this is an orthorhombic system. And this is non-centrosymmetric space group. That's why the value is minus, and 4 means it is face-centered cubic. Then symmetry operators, and then scattering factor and units are there. So this is the typical form of any instruction file. How the instruction file look like after the data finalization, we get the INS and SQL file. And then come to the systematic absences are there. There are some conditions. Suppose your cell is primitive, and there is no condition. H plus K plus L, take any value. And A, B, and C centering are the 3 type of centering. If A plus L is equal to 2N, then it's A face centering. And if all face centered, then all the Miller indices H plus K, K plus L, S plus K are equal to 2N. And there is some other condition for other lattice also. So if you look at this one, so if you add these values h plus k plus l, you will get the value -5, -2, -1, -8, and then again -8, and then 5, 7, 8. 5 minus 1 is 4, minus uh, 2 is 2. And you can see every value is s plus k, s plus, and can take any value. There is no either they are even or they are odd. And then come to the next file. Now you can see the sum of all the reflection is 10 plus 1, 11 minus 3, 8. It is always is corresponding to the C center lattice here. So this is actually the C centering. And then come the other HCL file. Now you can add the indices, then you will find that -3, -1, -1, then equal to minus, sorry, 5, -5. And then you can add, and then you can see this is corresponding to the all face centered absent. So from here you can get idea whether the centering is correct or not. So here I am finishing my this part, first part of the talk, and I will go for the next part, that is a demonstration of the software Olex 2. Meanwhile, if some person have any query or participant want to ask any question before are going to proceed further, you can ask. You are welcome to ask any question.
Hello, sir.
Hello.
So, how can we determine the space group by seeing the structure of the molecule?
No, by seeing the structure, we cannot determine the space group. The space group is determined by the symmetry of the unit cell. So symmetry is actually the fundamental. Unit cell is not fundamental. Symmetry make the unit cell. Unit cell will not make the symmetry. So symmetry will decide which space group, unit cell of symmetry of the unit cell. So there are actually two types of symmetry: crystallographic symmetry and molecular symmetry. Okay, molecular symmetry is when symmetry element passes through the molecule. In crystallographic symmetry, the symmetry element are not passing through the molecule; they are outside the molecule. But sometimes the crystallographic symmetry may coincide with the molecular symmetry. Otherwise, it's crystallographic symmetry which determines your space group.
Okay, sir. Thank you.
Any other question?
Sir,
Yes.
For curiosity, I'm asking. So, which type of this out of 7 crystal system, which type of crystal will form very quickly, and which type of form will form very late?
Formation of unit cell crystal system actually depend upon symmetry. If you consider the organic molecules, then we found the low symmetry space groups like triclinic, monoclinic, orthorhombic. But in case of minerals, then the higher symmetry space group is quite frequent. So it depends upon the symmetry, how the molecule pack together in a unit cell during the crystal formation. It depends on that. But the most, if you look at the database, CCDC database, the most common space group is P21 by C, which is most frequently occurring. Then the second is P1 bar, then some orthorhombic acid. So P21 by C is the most frequently occurring space group.
Sir, if you come in the next subsequent period, bring some examples, sir, so that we'll understand some more details.
Yes, now I have examples.
Okay.
I have selected some examples.
Okay, sir. Whenever its occasion comes, you just highlight in this angle, sir.
Yeah. So let me start for the structure solution part. Now what we have, I have some data, and here some 3 data I have. So if you look at the first one data, I have some INS file in the format like the name, I named it K1, and space group is P21 by C, and then there is cell and Z, and the corresponding error lattice is to 1, then symmetry, and this is the actual typical form of any instruction file. Either there may be some more instruction depending upon the situation, and this is a typical form of an INS file, and this is a HCL file. So you can see I have only these 2 files in the folders, INS and the HCL file. So let's start with these 2 files. So I have only 2 files, the INS and HCL file in the folder 1, named 1. And now upon the Olex, and I will drag the INS file into the interface. So you can drag and open the INS file here. So now it opened the INS file showing some molecular formula. This formula may be exact or not, it doesn't matter. We can correct it later. And then we have some resolution and I upon sigma values, and then RNT is the I already explained, it is merging R factors, and then completeness to 50 degree or 50.5 degree, 99.8. So it seems to be looking good. And then there is option home, work, view, tools, and info. Go to the work always. So there is first option is solve. There is small little downward arrow. Just click on it. So here there are programs, some which are used for the structure solution. I have put some programs here, like Select D, Select T. These are all written by John Michael Saldry. There is one other program, Superflip, and XM, XS is actually the counterpart of Select, and XT is the counterpart of Select T, and then Olex 2 solve. This is also the program by the Olex 2. So generally, I'm using Select T, which is actually giving very reliable result. So either I have to press this solve, or just I have to type solve here, and I just put enter. So it takes some few seconds to solve the phase problem, and it will give an initial model. Yes. So the structure is actually like this. And the I have chosen this molecule. This is actually a benzimidazole diamide. The structure is looking like this. This is benzimidazole, and then CS2 NHCO or some moiety is here. This might be changing. So this is the basic unit, and actually it's a benzimidazole amide moiety. It says. So I am getting this kind of structure here. So this is just the initial model, and the space group is P21 by C. So it's solely using the Select program, and then I will go to the refine part. I put this little downward arrow, and there is option for the refinement, Select Cell, XL, and Olex2. I generally using the Select Cell. Sometimes I also use Olex to refine. And there are two kinds, least square and CGLS. CGLS is quite fast, but it's not compatible with the ACTA. So when you need to save your time, then I always recommend CGLS. Otherwise, you can use the LS, least square. And cycle are the number of cycle through which it is defined. You can start from even with 0, 1, 2, 3, 4, 5, and 10. Generally, 10 is the optimum value. Then peaks 20 mean it will give you 20 Q peaks after each refinement. And then there is some weighting scheme. We will activate on it later on. Then these have their usual meaning. We will explain it later on. And then there is option ACTA. ACTA is used to generate the zip file. This is the command. So up to this, we have an initial model, which may be correct or not. We will see it after the subsequent refinement. So I will then press refine. Either I have to press this refine, this one, or I have just typed refine 10 cycle, and suppose I need 20 cubics. Then I will just put enter, and it will refine. So the initial model says the R factor around some 16%. This is famous R1, and this is WR2, weighted R factors. So now I'm getting some electron density, and now the highest maximum density is only 1.2 electron, means I have assigned all the non-hydrogen atoms. So now then I will put some more refinement cycle so that this shift gets stabilized. Now this almost getting 0, that's good. Now what is the next step? If you are satisfied that no atom is missing in it, then you can go for the anisotropic refinement. The anisotropic refinement can be done either by pressing this button. So there are two sphere or ellipsoid type. This is for the isotropic refinement. You just press it, it will refine isotropically. But when you press this button, the refinement will anisotropic. So either you have to put this button or just type anis and put enter, and then either you press Control R or you type refine. The arrows, there are you can see there are 4 keys on your keyboard: up, down, left, right. So from the up down keys you can always switch to the last command. So there is no need to type each and type. You can switch easily to the last command. And just I will type anis and press, and then I either press I control R, or just I press this refine or this one. Is only 0.6 electron in height. So I will different kind of hydrogens. There benzene ring, so these are aromatic hydrogens. On the sp2 carbon, there is methyl. So this is sp3, and this is also sp3, but this is methylene. And there is nitrogen amide, so there is ns. So it has different kind of hydrogen. So I choose this example so that I can explain the fixing of different kind of hydrogen in a single structure. So next is the addition of hydrogen. You can add hydrogen individually on each carbon, or you can add all the hydrogen at a time. Okay. So what you can do, you just type add, and just press enter, and it will add the hydrogen on the atoms. It may put some hydrogen wrong. We can see later on, but roughly it will put. Now you can see this CH3 has the hydrogen, the methylene. If you select this one, you want to see how the hydrogen is put, and just select this one and press this pencil sphere button, and you can see this carbon has the fx 137 and the 3 hydrogen atom and fx 0. This is the typical command to fix the 3 hydrogen on an sp3 carbon, fx 137, or sometimes it's fx 33. It depends upon this actual data quality. Sometimes the data quality is very nice. You can observe the electron density maxima around the carbon. Then fx 137 will work well. And when you are not getting the electron density maxima around the carbon atom, then fx 33 is a better option. So it will put. So this is known as the riding model. Riding model means as the refinement, as this carbon move, the 3 hydrogen will move along with this carbon. So this is known as the riding model. Okay. So if you look at this methylene, then the command is fx23, and there is minus 1.2. With methyl, you can see there was minus 1.5. With methylene is minus 1.2. Then come to the next type of carbon, that is phenyl carbon, and you can see the command is here fx43 and fx0. So this is a command to fix a hydrogen on sp2 carbon. Okay. So next step is to refine. Then you can do refinement, either type refine here, or just press Ctrl R, or just you can press this refine button, and it will refine now. Okay, now the R factor further drops to some 8.10%. Now I will refine one more cycle so that this shift gets stabilized, become almost 0. But I can see my goodness of it is not till around 1. This is still some off value. So I have to refine it. Maybe some I am missing some thing in my model. Otherwise, it should be equal to around 1. So then I press Control M. Okay, Control M will put the electron density map. So here you find 2 colors, green color and red color. Red color mean you have over assigned the electron density. Okay, and the green color mean you have under assigned the electron density. So this is looking quite green, means the atom present here is heavier than carbon. Okay, that's why green. And here red mean the element should be present lighter element, but hydrogen is the lightest element. Nothing is lighter than hydrogen, which means that we have wrongly placed the hydrogen here. We have to delete this one. Okay, so first I will get rid of this green color. What I will do, just put again Control M. It put the map of, I will select this and I'll make it nitrogen, and I will refine this. Now you can see the R factor will drop a little. It will become 7.65. And now if I put the map is looking much cleaner. So now the atom assignment is correct. But now come to the some part here. This is becoming red. Mean this hydrogen should not be there, and this is again red. So these two hydrogen are wrongly placed. So what I will do, I will select these hydrogen and just press delete button on the keyboard, will delete this. Then I will refine it, and now the R factor is around 7.65, and now it's coming down to 7.29. That's okay. Now I will again press the Control M, and I will found two more dense green regions are here. So mean the hydrogen are missing here. So these nitrogens should have the hydrogen. So these are the acidic atoms. Nitrogen and oxygen are acidic. So on the if you when put hydrogen on acidic atoms like nitrogen and oxygen, be careful. Be sure it is present actually there. Sometimes there may be deprotonation. So first care of this, whether the actually hydrogen is present or not. I put this electron map off by pressing Control M. Now I can see the very electron density are very close to this nitrogen atom. So what I will do, I will not using the Rydell model. I can use the Rydell model. I just put add 43. It will add. But I will adopt another strategy. This is known as the semi-free refinement of the acidic hydrogen atom. I will select these hydrogen and I will name them hydrogen. So, and I know there are standard distance of NS and OH. So I will select these bonds and I will type defix 0.88 angstrom and press it. And then I will refine it. And now you can see the R factor is further dropped to 6.93. I will refine further some more cycles so that this shift gets 0. And now it's getting close to 0. Okay, that's good. Now I am at the almost at the end of the refinement. I put the Control M map. Now you can see the map is looking much cleaner, and there is no green or red maxima. There's some red color here. That is due to some thermal vibration of this ethyl chain. As we know, the alkyl chain are famous for the thermal motion. So otherwise, the map is looking very nice. Then I will put the weight scheme on, and then I will refine again. Okay. Then there is some orange circle is there. I just press this one. It's showing some fractional number. That's why it's showing fractional number, because when you check the G dash value, it's around 2.75. G dash is 1. I will put is 1. Then this is looking reasonable. As C34, S32, and 6 and O2. Now the formula is also looking good, and I will now refine it. Okay, so now you can see there's still orange. I'll just refine one more time. So it's refining. Now you can see everything is green. The D minimum is 0.66. I upon sigma is looking nice. If I press this, I can see the crystal is very nice, and it's diffracting up to 58 degree to 2 theta 58. After that, there's noise actually. This is the line, 3 sigma line. I upon sigma equal to 3. So any value above this line is data, and any value below this line is noise. So I can see the crystal is very nice diffractor. Although I can the data at, cut at here, omit, I can use the omit 058 here, omit 058, because after 58 there is no data, there is only noise, and I will refine it. And you can see that factor further drop to 5.92%. I will refine some more cycle. So now you can see the I upon sigma improve from 30 to 40. And the RINT is very nice, 2.7%. And refine one more time. Okay. So now everything is looking nice. And if I go to the this, I will press this percentage button, and now you can see the F observed and F calculated are matching almost exactly with each other. Now the refinement is converges and the model is looking nice. Then there is certain information is there. If you look at the refinement indicators, there is everything in black color. No, nothing is in red. If something is in red, you have to take care of this. And then come to the bad reflection. There is no bad reflection. All reflection looking nice. And then reflection statistics are there. There is some kind of plots. There is a plot, fractal, yes, fractal dimension. And just look at the fractal dimension curve. It will take some 1 to 2 seconds, sometime 10 to 15 seconds also. But it will show you curve. Sometimes it take more time depending upon the size of your structure. Okay, now yes, here. So this should be symmetrical about this central line. So now you can see it almost symmetrical. There is some dissymmetry here. Otherwise, you can see almost it's looking nice. So there are some other curve also which have their usual meanings. We can see, we can check each and every plot. And now next come back to the structure. Now the next step is to we have do some systematic numbering. You can see this carbon is C00P. This is C00M like this. So what I can do, I will do some systematic numbering. So first is just I am doing random numbering. What I will do, I will go to cell $C. It will select all the carbons and name 1. It will start from 1 and it will go up to the 34. Okay, enter. Then what I will do, next cell $N, and I will press name 1. Then I can also select like this O1 and this O1, and I will name 1. Then next step, next one is fix HL. Fix HL mean it will fix the hydrogen as per the atom name. Suppose you have C2, then it automatically place H2. Suppose you have C27, it will place S27. Suppose you have carbon, some ethylene carbon C15, okay, then it will place H15A, H15B. It will do some systematic numbering, okay. Then I will do sort. Sort means it will sort all the hydrogen like O1, O1, O2, N1, N2 like this, okay. And then I will refine. Okay. So it will be refined. Okay. Now everything is green. That's a nice sign. And now the structure is almost finished. Okay. Then what we will do? We have to generate the reports. What we will do? I put QPix off. Then I will type clear. Okay. Now I can draw a diagram. I can do the numbering. There is labeling. There is option. Go to there is option draw, and there is option. Yes, label for generally we are doing label for the non-hydrogen. You can do the non-hydrogen label, and then you can place with shift and left mouse key. You can move this label to anywhere. So with shift and left mouse key, you can move these label, and so you can place these atom at the appropriate place so that they cannot be hide in behind of each other. Okay, so this is the outer diagram. Then you can draw the image, nice image from here, bitmap images. And just go from here JPJ, or there are several options actually, PNG, TIFF, you can save in any format. And then there is some resolution. I generally put the maximum resolution 600, and then width, I generally put the maximum width, and then you press just go, and it will show a JPG image in your image folder. And but before I have to generate the tables. Okay. So for table, now you can first check the shift. I will type edit shift. Okay. So it will open my zip file. Here you can see some entries are still missing. Okay. So either you have to fill these entries by hand, or there is another option in the Olex to go to refine. There is option report, and now there is option collection. So you can type your sample ID here, then go to crystal. Okay, and then systematic name you can type it here. Then color, there are metallic, dull, or maybe clear. Then you can type it light, or maybe colorless, or anything. And then shape. If you have face indexing, then you have shape score 0.12. Any shape I have to put score 0.14, 0.22, and it's looking like globe. Then there is some personal detail. You can put crystal mounting on final capillary or in a brass tube or anywhere. And then come to the diffractometer. The diffractometer generally FX4, Brooker D8, also diffraction. Then temperature at which you have collected data. Suppose I have collected data at 298 Kelvin, room temperature. Then special detail you can fill. Then absorption correction. There is option absorption type. Generally, the absorption type is multi-scan. And then absorption detail is SADAPs, SADABs for the single crystal, and it's twin abs for twin crystals. And maximum minimum will calculate by the software. Suppose I am taking any arbitrary derivative right now, 0.857, minimum maybe 0.741, and then you can, these are enough. Then you can refine it. Okay, then it will put all the these entry into this sheet. This is the one way, and the second way is just we have to edit this sheet. And you have put the values, you know some systematic name, maybe benzyl, imidazole, amide, like this, something like that. And then there are some entries that are automatically filled. Then there is section used, you have to fill it some values. Okay. Otherwise, when you do the data finalization, the files are generated which have these all entries filled, and the SIF will automatically fill the data from that file. So I always prefer do not merely start with the two file INSR scale. Keep all the relevant file in the same folder, so that you need not to fill these entry manually. It will automatically extract from the value. Now you can see the multi-scan steps are there, and the entries are filled. And then, okay, this I'm going to put it save. And then I will go for the option report. There is option no image, or you can put some suppose screenshot here, this screenshot here. Generally I clear it. And then there is option HTML report. Okay. So it will generate a report like this. Okay. And you can Control A, Control C, copy this, and you can save in only Word as well. Just go here, and there is option for new Microsoft file, and you can paste here, and it will generate a very nice report here. And okay, so yes, just some beside it. Okay. So now you can see it generates a very nice report which can be edited, or which can be copy and paste on the Word or PowerPoint, whatever you can to copy it, you can copy it. Now this will give you the detail of this is known as the main table. And then there is option for the fractional coordinates and anisotropic displacement parameter, and then bond lengths, bond angles, then torsional angle if you have put the conf command here, and it will give you the hydrogen atom coordinates. And then there is small description like single crystal of this were grown by that suitable crystal was selected, and this will write some mini report for you. Then there are some references which we are using. So these three references we are using, and then it gives a brief description of the data, and then there's some other details. Okay, so this is a file, and okay, so this is the one. This was the first structure which I illustrated. So if any query, you can ask. Otherwise, I will move to the next file.
So the last part I didn't understand, that how you copied it and how you pasted.
It's very simple. Just go to the here. Okay, this file. Just say Control A, Control C, and Control V.
Oh, how you generated this file? I didn't understand
Okay,
that.
okay. Here you can go. This software. You can go here. There is option report. Okay. There is option HTML report. Just press this, and it will generate the report.
Okay, sir.
Okay.
Yeah.
So okay. Next, let's move to the next file. Meanwhile, let me close the other window.
No,
Hello.
no.
Yes, yes, please.
If you do not get the all non-hydrogen atom, then how can you add this non-hydrogen atom in the difference Fourier map?
No, definitely, you will get the non-hydrogen atom into the difference Fourier map. Sometime due to disorder.
No, not at all. There is a problem.
Yes, yes, I will discuss it. But sometime due to the disorder, due to the high
Yes.
thermal motion, some atoms are not getting visible in the difference Fourier map. Then how to get rid of that problem? That I will discuss on the following talk when I will discuss how to handle the disorder structures.
If you have the 15 carbon and 1 nitrogen, then 16 total 16. But your in solve the structure, they throw only 10 atoms. Then what to do?
Sorry, can you repeat it?
If the non-hydrogen atom is 10 or 20,
Okay, suppose there are 20 non-hydrogen atom and you are getting
20,
only
then the first solve structure, when you run the solve, it will give the only 10 atoms.
okay, okay. I am coming to that also. Actually, second example is dealing your this query.
Hello.
Okay, in Olex.
Yes, in Olex. Yes.
And how is incorporate the Olex in Olex?
Okay. Just go here. I have put my Olex here somewhere. Just tell me where it is. I named a folder SAXI. I put my all the file here, and then I give a path. Then go to home, and there is option setting, and you can see you can give a path. For example, I put Orca in C and I give a path. So put anywhere selects and give just a path. You have to tell Olex to where is your SLX file. It will take automatically. So from a path you can do that easily. Okay. So can I move to the next
Hello.
example? Oh, okay. Okay. Yes. Someone.
Hello, sir.
Yes, please. Yes.
Sir, could you please tell what is the significance of C137 or C23?
Sorry.
C numbering C137 and C23.
Okay, okay. That is actually the code for the different kind of hydrogen to be fixed. For example, if you fix the aromatic hydrogen, the default code is FX43. So these are designed for the SELEX program. It will read this code and it will fix the corresponding hydrogens.
It is constant for aromatic.
Yes, this is fixed for the aromatic hydrogens.
Okay.
There is SELEX manual. If you read the SELEX manual, you will find all the commands there.
Okay, sir. Thank you.
Okay. So let's move to the next example.
Sir, one more query.
Yes, yes, please.
Sir,
I have one doubt.
hello.
Hello, hello. I am listening.
Sir,
Yes.
yeah. Suppose if we have an alkyl group,
Mhm.
let it be butane.
Butane, okay.
Yeah. So in butane, when we are transferring to Olex, if one carbon atom is missing or the bond between two carbon atom is missing, so what we'll do? How to make the bond of the atom, missed atom?
I will handle the disorder in a separate. I dedicate full lecture on this disorder structure refinement.
Okay.
Otherwise, it will become too lengthy.
Okay, sir. Okay, fine.
So anything, any doubt about the disorder, you can ask on that day. You are highly welcome.
Okay.
Okay. So can I proceed further? There is some question.
Sir,
in the chat
one
box.
question.
Yes,
Hello,
please.
sir.
Yes.
Sir, that you went there in a report, I think refinement indicator and bad refinement. Please show when we are doing what are the parameters. You already made a refinement, then you went there. So before going to final one, just show there, means while doing the refinement,
There is option
how
info.
that bad refinement or
If
indicator
I will find any bad reflex, suppose
coming.
there is some bad reflection.
No, that you, how it will come there, that's my question.
Uh, yes, sir. When during refinement. Can you repeat the question, please?
Yeah, that's what is the bad reflections and those things.
Bad reflection means which are not fitting into your data. Okay. Suppose some reflection are showing more deviation. Okay. Then you have to omit them. Otherwise, it will ruin your model. Okay. Then when you remove the bad reflection which are not fitting in data, then it will improve your model. Okay. Whenever this kind of data will come, I will show you.
Hello, sir.
Okay, sir. Yeah, thank you.
Okay. Then sir, why did you use defix 0.88 after selecting the NS and OH? Yes, because when you fix the hydrogen on some acidic atom like nitrogen and oxygen, you have to be sure it is present there, because these are acidic atoms and there is chance of deprotonation is always there. So when you are not getting the cubic density or electron density maximum from the Fourier map, then be careful. First, make sure it is present there or not. If it is present there, then you can only fix. Otherwise, don't fix it. And when you are very much sure, then you have to fix only. So that's why there are standard distances of NS and OS distances. The NS distances are 0.8 and OS distances are 0.84. You can find this value in any standard research paper. That's why I'm using this defix command. So I am using the semi-free refinement for the acidic atoms, and I am using the riding model for the phenylene, methylene, and methyl carbon, because I am sure there is hydrogen on phenylene carbon. There is no doubt, because the removal of proton from benzene is quite difficult. We need a very strong base to remove that proton. And in methyl, there is, I am sure, methylene is also, but from NH, it may be deprotonated, maybe because during crystallization, some bicarbonate ion present. The bicarbonate are strong enough, they will remove the hydrogen from the oxygen or nitrogen. So that's why I am using that strategy. First, I have to locate whether is actually hydrogen is present on the nitrogen or oxygen. I have answered the question. Can
Hello. Sir, just one query. Hello.
hello, yes, please.
Sir, is there any harm if one can remove the bad reflection from R1 percentage option in Olex 2?
Yes, sir, we are moving bad reflection because we are sure this is not the part. But in case of sometime tuning, some reflection definitely not fitting into the unit cell because they are belong to the some other units.
Sir, can you go Olex 2?
Yes.
Uh,
Hello, can you repeat the question, please?
we could not see. So Olex 2 software. Olex 2.
Okay, because I am just taking your queries. That's why you are not able to see the Olex software.
Can you go, please? Yes.
Okay, so
Then,
let
percentage of R1 percentage.
Mhm.
Please click that R1 percentage. Percentage option. Yes.
This
Yes.
is R1.
Yes. That one.
This one.
Percentage.
Percentage. This is just percent because we are normally reporting the.
If you click that option.
Yes. This will show you the graph.
Yes.
Yes.
There I am saying.
That's I have discussed in my PowerPoint slides. You have F observed. These F observed is stored in INS and HCL file, and then we have calculate the F. Then we are matching these F observed and calculate, and we will bring them close possible to each other. Now they are as much as close because they are almost lies on this straight line. Okay. In the next refinement, I will show you the intermediate value of F observed.
Hello?
Yes.
Sir, I totally understand what you are saying.
Okay.
I'm saying if there is some distraction from the line, that straight line.
Yes.
Then one can delete from that graph also.
Yes, sometimes it may deviates from this line, that will maybe due to the some problem in the data reduction or data integration, then you have to check it.
Actually, if we double click the diffraction spot, then it is automatically deleted, right?
Yes, yes, I will explain it later on how to delete this.
Okay, sir. Thank you. Okay.
Okay, then let's come to the next example, number 2. And this is very similar compound, but it's some different space group. I will put this INS file on, and then some showing some. Now you can see the I upon sigma is 18.3, and RINT is higher. So this data quality is not as good as the previous one, but still let's see. Then go to the sol. And now I will use this sol button instead of typing sol here. I will just put this button on, press this button, sorry, and I will see some structure are there. Okay, so there is benzimidazole moiety, then there is methylene, NH and CO, then there is some biphenyl. Okay, so I was expecting 2 benzimidazole and a biphenyl, but I am getting only half of the structure because this is due to space group symmetry. The space group is C2 by C. Now the lattice is not permittive, the C-centered lattice. And 2 mean there is 2 fold axis and there is C-glide plane. And the 2 fold axis and C-glide plane, when present, they will generate an inversion center. So there are 3 types of symmetry element present: the 2 fold axis, C-glide plane, and the crystallographic inversion center. So I am getting this model. So first, what I will do, I will refine it. Just I will press this button, refine, and there is refinement. Now I can see the maximum electron density is only 0.8 electron, means I have assigned all the non-hydrogen atom, but still I can see my structure is not complete. Only half of atom are there because the half are generated from the symmetry. How I see this the symmetry equivalent of this molecule? Just I press Control G on the keyboard, and I will press it. Now you can see this other molecule is generated from the symmetry. So they have inversion symmetry. Okay. Now how to see these symmetry elements? You can go to the mercury and you can open there. I'm going to demonstrate it first. And then I will open the mercury here, where I put the mercury files. Mercury, where is mercury? Sorry. Yes, here it is. I will open this. Meanwhile, mercury will open. I will go back to the Olex tube. So this is the complete structure. So now the asymmetric unit has only half of the molecule, and the remaining half is generated by the symmetry. Which symmetry? Either it may be generated by the C-glide, or by the 2-fold axis, or by the inversion center. We can see in the some visualizing software like mercury. So now I can see there is carbon, okay, then nitrogen, then carbon, nitrogen. Now I think all the atoms are correctly assigned. I will refine one more time so the shift gets stabilized, and I will put the weighting scheme on because all the non-hydrogen atom has already assigned. So I put ACTA on to generate the shift file, and I will refine it. Okay, so this is actually the ground structure, but you can go back to the asymmetric unit, but just typing fuse, 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 and it will go back to the asymmetric unit. Okay, so now let's come to the mercury. You can download the mercury, and I also shared the installer with you in the drive. You can download from there. If you find any difficulty, then you can install that. Now let's come to the that file. Where is that file? I put that file here in second one. So this is a zip file. I just open it, and this is actually the complete structure. But I will just go to the asymmetric unit, and this is showing only the asymmetric unit. Now I will go to display, and there's symmetry elements. Okay, these are the symmetry elements here. Okay, so just put this glide off. So these green are the actually 2-fold axis, and this is the inversion center. So here it is the inversion center, which is generating these rest part from the first part. So it is generated by the actually inversion center. Just put it. Okay. So here you can visualize the symmetry elements present. Generally, symmetry elements are present in the unit cell, not in the molecule, because this is crystallographic symmetry, not the molecular symmetry. Then I will show the glides and okay, and then I will show the packing. So this is the packing of your molecule. Here you can visualize the different kind of symmetry elements present. So these symmetry elements are present in the unit cell, not in the molecule. Be remember. So this is the symmetry element of the unit cell. You can visualize, of course, in along some different direction. So you can see the sorry, twofold is actually passing from here. Just I'm going to unpacking it, and just I'm going to asymmetric on it. So yes, you can see this node, sorry, generated by the node generated by the crystal of intelligence center. I apologize. Is generated by the twofold axis. You can see that this is twofold axis, and the one part, the mirror image. Sorry, when you rotate this by the 180 degree, you will generate this. So this is the symmetry elements. So the twofold axis actually generating the one half to second half of molecule from the first half. Okay, let's come again back to here. Then when I assigned all the known hydrogen atoms, then my next step is I will refine anisotropically. Last time I type anis and refine. Now I will just press this button directly and it will refine it anisotropically. The next step is I hydrogen add. Now you can put press this button and now we'll add the hydrogen. Okay. Now you can see the hydrogen are placed on the corresponding atoms, and this is methylene. Okay, and there is no actually hydrogen there. This distance is 1.31 and this distance is 1.35. So this is CN single bond and this CN double bond. So there should be no hydrogen. When you put the map on, you can see there is green area here. So we are missing actually hydrogen here. There is no hydrogen, and this hydrogen is just okay. And then what I will do, I will put map off. I will select this one. I will say hydrogen, and I put defix 0.88, and I will define it. Yes, R factor is proved, so means I'm doing right thing. Now you can see the hydrogen is placed on it. Now there is no hydrogen because here it is generated by the symmetry. Just I put Control G, and from here it grows. Okay, so some kind of intramolecular hydrogen bonding is there. Okay, just I'm going to press escape. So this is a complete molecule. Then next step is I'm going back to fuse again. And then next step are some, you have to put the systematic numbering. Suppose now I want to put this as carbon 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I type name 1. It will type from 1 to 15. And suppose I want this should be number 1, number 2, and number 3. Okay, then type name 1. And this is again name 1. Then I will do the fix HL, and then I will sort, and okay. And now I will refine. Okay. So now when you press this one, you will see all the atoms here, O1, O1. So only these atoms are present. The remaining are generated from the, of course, symmetry. So it's complete the refinement. Thereafter, there is some intramolecular hydrogen bonding is, of course, there. So this is from symmetry. Then how these molecules are packed, you can see, just type here grow. You can type grow, sorry, grow, and it will grow like this. Okay. Then you can see the packing, how the molecules are packed together. Just type pack, and it will pack like that. Then how to see along the different directions. When you want to see at the A axis, then type matter A. It will look like this. Matter B along the B axis. It will look like this along the C axis. This diagram is generally used when you show the packing, how the molecules are packing with each other through the hydrogen bonding or through the pi stackings. And then I again type the fuse, and we will go back to the asymmetric unit. Okay, so this is the example of symmetry. So sometimes we are getting only half molecule. Sometimes we are getting only 1/3 molecule. Sometimes we are getting only 1/4 molecule. Sometimes there is fourfold axis, tetragonal cases. So only 1/4 of molecule is present, and the remaining 3/4 is generated from the symmetry. And sometimes the molecular inversion center, we have only half molecule, other half is generated from the symmetry. So this is an example of symmetry. So before going to the further example, I want to take some queries. If you have, please, you can ask your queries. Yes, now you can see the graph. It is not as good as the previous graph because there is some problem with the data. You can see the crystal is a weak diffractor and it is not diffracting beyond the 44 degree. So IUCR limit is there. This red line is the IUCR limit. So this should be diffract at least there, but it not diffracted to that level. So the data quality is not as good as the previous one. But still, we can publish our data. We just have to mention that we have tried a number of crystals. The most suitable crystal was only diffracting up to that limit. So you can convince the referee there is no problem. Then you can see, okay, then info, there is some refinement indicators. Yes, there is some radar there because the crystal quality is not looking so nice. So I think there is no mean to keep the data at the, suppose, 57 degree. We can cut the data at 50 degree, just typing omit 0, 50, because 50 is the minimum limit. You cannot go below this. Sometimes in special circumstances, you can go up to 48, 46 also, but you have to mention the reason why. Okay, just I'm going to press Control R to find. Now you can see the red entries are gone and every entry is looking black. So I have to cut the data at the 50 degree. Although I lost some important information, but my model is getting better, and I am getting this 22 instead of 18. Now it will become orange. So orange is that's okay, but it should not be red. Okay. The refinement indicator are good. Now then go to bad reflection. The reflection are not bad. They are almost looking nice. And if I look at the graph, it's a little bit improved, but still it has some problem because the crystal is a weak diffract. And then you can check the different kind of graphs there. But I have completed this structure here. So before moving to the next example, if there any query from any participant, I will happy to answer.
Sir,
Yes.
I have just one question, sir. Sir, like for your compound, right? That you're showing like all the atoms to suppose carbon, all the carbon atoms are of equal size. Suppose if one is bigger, is that just a distortion?
Yes, bigger mean this molecule has a higher degree of vibration. Okay.
Okay.
So
Okay.
that's why it has some more orientation in the structure.
Okay, that will be solved in the distortion part.
Not distortion. It is maybe some kind of disorder, vibration, thermal vibration. When you suppose collect the data at room temperature, then you will get the size of the thermal lower. Suppose there's command TELP 40. This is 40% thermal ellipsoid. 40% thermal ellipsoid means the space occupied by the 40% of the electrons. Suppose carbon has 6 electrons, and you are drawing at the 40% probability level, means the 40% of 6. That much amount of electron occupies this space. If you occupy this space more, then there is more thermal vibration. If it becomes small, then there is less thermal vibration. So when you are collecting data at low temperature, your thermal motion will remain into the control. So you will get the smaller sphere. Just take a crystal, take its data at the room temperature and also at the low temperature. Then draw the diagram at the same probability level, and you will see that the size of thermal at low temperature is smaller than the room temperature data. Okay. So generally, it depends upon the size of thermal. We can take the value of any tab to 20 also, so that we can see these atoms not overlapping with each other. That you can decrease the, of course, the bond length also, so the bond thickness also. They go to option view, and there is option bond. You can make the thin also here. Okay, that's much I think good. Okay.
Yes, sir. So that means that is not a distortion. That means that is like
not distortion. Distortion is something else. Disorder. I will discuss that disorder, thermal motion, on this.
Okay. Thank you, sir.
Yeah. So can I further to move to the third example? Yes.
Sir, that whatever commands you are giving, where will you get those commands, sir? You are giving direct commands.
Are standard. You can find these command in Olex manual or in Selex manual.
Okay,
Selex manual is available. You can download from it here. It's freely available.
Okay, sir.
Okay, but
Sir,
just
actually,
I want just there is some commands there. There is a book which I already mentioned. This one book. So this book have these commands written. There are option the hydrogen atom. The chapter number 3, the hydrogen atoms, and these commands are already written there. Different commands, which command use for which type of yes. Fx 13 for the CH. When you have only one hydrogen on sp3 carbon, when you have two hydrogen on sp3 carbon, when you have three hydrogen, okay. Then for the aromatic one, for the iodide iscan YT, then F6 1 to 3 137. 147, 163 for the if you have acetylene ethyne carbon, then 163. So these are already set standard reference. You can find these in any selection manual or in this, any particular book. Yes, if there's any more questions.
Hello, sir.
Yes, yes.
Hello, sir.
Yes, please ask
Sir,
your question.
in OLX2, so please show the OLX2.
Yes, sir.
Actually, I think there is some mix of two questions.
Sir, OLX2, please show the OLX2.
Yes, there is Olex too.
Sir, here in your case, there is 100%, right?
What? Yes, full data completeness.
Yes, sir.
Yes.
For my data case in my system, it is showing 88% and it is showing red.
Yes,
Can
yes, yes.
then how can I make it green?
Any value less than 98.3 will show you either in the light green or red. Means your crystal is weak diffract. Just cut at 50 degree. If it complete to 100%, then it's okay. Otherwise, I always suggest before the demount of your crystal from the goniometer, check the completeness of your data. Okay, so when you collect the data, you demount your crystal immediately. Don't demount it. Keep on mount on the goniometer and check whether data is complete or not. If you complete, then you can demount your crystal. If you found this the data completely is less, then you have to collect some more data, and there is standard option to append that data with the earlier data. So I always recommend before demounting crystal, check the completeness of your data.
Excuse me, sir.
Yes.
Sir, I just want to know whether how we can reduce the goodness of fitness parameter in case of like, in my case, it is metal organic framework. So in that case, how I can reduce that goodness of fitness error? Because it is showing red only how many refinements I'm doing. So it is just showing the red.
There are several reasons behind this. The space group may not be correct. The data is weak. There is some unresolved disorder. There is some unresolved twinning. Okay, and there are some missing atoms. There is some poor absorption correction. There are several reasons there. So it can be find out only when then there is close examination of the data, that we can say after only that we can say that why the goof is not close to one, why it is deviating from one. So there are several reasons. You have to find which reason. Sometimes we have assigned wrong atoms. Okay, so some metal assigned wrong, cobalt instead of copper. Okay, manganese instead of iron, like this. So there are several reasons for behind this.
So can you show one example with the metal organic framework for the crystal structure elucidation? Like,
okay, right now I don't have the example, but if you want to show any this kind of example during the talk, then you can send your data. If it is published, then I will demonstrate it with the participants. Otherwise, if some other person have this MOF data, then he or she can send me, and then I will demonstrate in my subsequent talks.
okay, sir. Okay, sure.
So let's move further to the
Yeah.
third example. Okay, so let's move to the next example, and I am moving to the third example. Third example is also very related to this one. Now I have some lattice solvent involved in the structure. So now there are some initial statistics. Then I will go to work. Then I will go to the option select T, and I am going to solve it. Okay. So now
Sir,
this is
actually, sorry to interrupt.
yes, yes,
Hello, sir.
yes.
Sir, actually, sorry to interrupt. Actually, in my system, this program option, when I'm drop down this program option, it is not showing any selects. It is showing only OLX2 dot refine. Is it
Yes, yes.
any like,
Because
yeah, that
because
is only showing.
yes, because you are not having the selects program. This is already set in the Google Drive. Just download it and put in the C drive. Okay, then it will show. You just can put go here. Suppose I have my Olex here, and there is program 586. Where is Olex? There is my Olex 2. So just put copy and paste all these files, select file here, then close your Olex2, restart it, and then you will find in drop down box all these programs. Okay, try it. If you still find some problem, then let me know.
Okay.
Okay. So
Same question I asked you.
yes, yes.
Okay, thank you.
Yes, please ask.
I think Sir is saying he also facing the same thing.
Yes, I same. And another thing, you cut the reflection file 60 to 50, but in reviewer or paper reviewer or see all these these in zip file, so they can ask to recollect data or something else.
Yes, yes. It depends upon the reviewer. When reviewer see your data, the reviewer is an expert crystallographer. He can understand the situation. Okay. So if there is any possibility and you are cutting the data without without no any significant reason, then reviewer may ask, don't cut this data, take this full data. And when you see, because when you include the data after a certain limit, it's just increasing noise and is not doesn't contain any useful information, then it is logical, seems logical, you can cut the data.
Another thing is that you said in room temperature, the thermal vibration is
Higher.
bigger.
Bigger.
So it will hamper in the R value also.
Yes, definitely it will hamper because you are getting an average position of particular atom. Okay. So that
So in room temperature, we are not able to down the R value
to a certain level, below a certain level, you cannot
below
go.
a certain level.
Just choose one crystal, collect this data at room temperature, collect this data of same crystal at low temperature, refine it. You will see the difference.
Okay, sometimes it is not possible. You have to give the two collection data two times.
Yes, that's why I will always say, I will always prefer, if you have a choice between low and room temperature data, always collect a low temperature data.
Yes, yes. Thank you.
Okay. So let's move to the third example. Now this example this is actually the hydrochloride salt, which I have prepared. Earlier, this was very insoluble compound. So definitely I have prepared the hydrochloride salt. So there should be the chlorine atom in there. Okay. And there's some nitrogen are showing. Of course, these are not nitrogen, these are water molecules. So I will select these atoms and I say these should be oxygen. Now every atom is almost exactly correctly assigned. Hydrogen are sorry, carbon are carbon, nitrogen, oxygen are. Then I will refine this. Okay. Sorry. So now maximum peak is around 1 point electron. Just there is command assume some $250 Q. It will increase the size of your Q peaks. So now you can see them very clearly. So I will see where is this peak is situated. Just I will press this one, and this Q peaks is automatically selected. So this electron density is coming around the chlorine. So chlorine is quite not very heavy atoms, but is heavy as compared to the other atom. So there is always some Q-peaks density around the chlorine atom because the vibration are more for the chlorines. Chlorine is the molecule which is mostly disordered. That's why I'm always saying avoid DCM and chloroform to crystallize your compound, because chloroform and DCM are highly disordered. So anyway, now you can see the data is looking very nice. There are two electron density maximum on this carbon. This is methylene carbon, and they are looking very nice. And some Q peaks are in between this carbon, means this benzene is showing some kind of disorder. Whether we need to model disorder or not, then it will see after the anisotropic refinement. Otherwise, we can clearly see these three carbon atom are showing some kind of disorder. Similarly, these carbon are showing some kind of disorder. From the initial assignment, the methylene carbon are very nicely visible. And then what we do next, I will do the anisotropic refinement, because all the non-hydrogen atoms are assigned and all the atoms are correct. Now I will refine it anisotropically. Yes, now you can see these carbon are have some elongated ellipsoids as compared to these carbon. So mean there's some kind of thermal vibration there in this ring, but this is not so severe, so we have to model this order. Now you can see the every hydrogen you can see very clearly. Okay, so what I have to do, I will put the next step is put the hydrogen atoms. So I press Control Q, it will remove the Q from here. So always you can toggle between Control Q, second time Control Q, it will show peak, then Control Q, it will disappear. So this will, in this way, you can always toggle between the Q peaks. Okay. So now I have put the hydrogen. So these are actually the aromatic hydrogens. So I am sure there should be hydrogen. So I will select the, I can select manually. So I will put the sure hydrogen, which are present there. So I select this and I will type HAD or HAD 43. Both will work the same way. Put. Okay. Now next step is this is methylene. So it will automatically put the hydrogen here, or I can type SI23. Okay. Now the hydrogen are left only on the nitrogen and the water molecules. So now I put back Control Q and I will define it. Okay. So just I will put the again zoom command. Now I can see the maximum electron density 0.5. It is here. It's appearing here. So this hydrogen is, sorry, this nitrogen is protonated, and this nitrogen is also protonated. Okay. So earlier there was only one NH and there was C double bond N, but when I mix the hydrochloride salt, the second nitrogen also get protonated. So I will select this and I will make it hydrogen, and I put defix 0.88 and I will refine it. Okay, let's go further. Okay, now it is reasonable when there is some electronegative atom, it will definitely show some hydrogen bonding with this acidic atom. What is the hydrogen bonding? The distance should be less than 2.0 plus radius of the acceptor. So in the hydrogen bonding, what we have donor, then hydrogen, and then acceptor. So what will be the hydrogen bond? What is the condition? That it should be less than 2.0 angstrom plus radius of acceptor. If this bond length is less than this, then it is a hydrogen bond. So there is simple definition. What is hydrogen bond? 2.0 plus radius of acceptor. Okay. Then I will define it. And now I will go next to the 0.4 electron. Where it is here. So there should be another hydrogen atom. I make it hydrogen. I again defix and I will refine whether there is any improvement in the R factor. If there is improvement, I am doing the right thing. Otherwise, I have to check. Okay, then next go to next highest electron density. It is here. make it hydrogen. Again, I am putting the constraint defix. I'm going to refine. If there is any improvement in R factor, then I'm going right. Otherwise, I have to say, yes, there is improvement, 5.71, good. Then I go to the next electron density maxima. It is here. This would be another hydrogen. I again defix it, and I will refine it. Okay. So, okay, then next electron density maxima is here. Yes, this is another hydrogen. I make defix again, and I'm going to refine it. Yes, 4 point, that's good. And now the next electron density maxima is here. This should be hydrogen. I am again refining it with fixed distance. Sometimes the data quality is very nice. There is no need to defix. It will work freely. You can first try freely. If it's deviating from its position or your refinement is not getting converted, then you can defix. And then there is hydrogen, hydrogen, hydrogen. Now every hydrogen has fixed. Now I will go to the water molecule. Okay. Now just look at here. The two electron density maxima are clearly visible. Okay. So these are the hydrogen of this oxygen. I will select hydrogen. I will fix these distance, defix 0.84, and I'm going to refine it. Okay, so now it's showing some lesser distances. There's some bond between two hydrogen atoms. If I'm going to select it, this distance is some 1.08. Okay, so what I have to do, I will defix this distance to 1.35. Now it's looking reasonable. What is the bond angle between? What is the bond angle in water molecule? It's some around 105 degree, I think. Then I go to select three atoms. I type cell, and it shows some bond angle of 98 degree. So you can further increase this angle to reasonable geometry. Otherwise, it's looking reasonable. Then I will go with it first. Then come to the next water molecules. Now you can see around this oxygen, there are 3 electron density maxima, but only two are reasonable. So if you look at this one, select this one and type cell, this distance is 0.87. Distance is looking reasonable, and this distance is 1.032, little longer, may be possible, and this distance is 1.005. So all the 3 cubics are in the bonding distance. So, but I will choose a reasonable geometry. Okay, so I think this hydrogen and this hydrogen should be there, because if I make this hydrogen, then this distance is 1.4. This is very close. Okay, so this should not be the hydrogen. These should be looking reasonable. I make them hydrogen and put some defix command. Okay, also I first refine. I'm not restraining the angle only. I'm restraining only the 1 to distance. I'm not restraining the 1.3 distance. I'm just going to refine it. Whether it is yes, now it is looking stable. Yes. So I will not further put any more restraint. If it deviating from its position, then I will have to put some more restraint. Okay. Then come to the third water molecule. Now you can see there are clearly 3 electron density maxima. So with the chemistry knowledge, we have to choose the most suitable one. This should not be the hydrogen. Otherwise, these hydrogen will become very close to each other. So this around 1.8. So I will avoid this one. I will choose these hydrogen and make them hydrogen, and this putting distance, defix, and I will refine it. Okay. So now other further down, that's good. Now the electron density maximum only 0.2 electron, and it is here. So this is meaningless. It doesn't make any sense. So now I have put all the kind of hydrogen atoms. Now you can see there is some bonding there. This is hydrogen bonding. What is hydrogen bonding? It is equal to 2.0 angstrom plus the radius of the sector. Any value less than this is a bond. And then what is a bond angle? A bond angle should be greater than 110. Okay, it should not be less than 110. This is the definition for the hydrogen bond. So any angle. So suppose this one, this angle is, I am going to cell. Cell is the command. Okay, this distance. Sorry, this angle. This angle is 106 degrees. So this coming down. So this is cannot be considered a hydrogen bond. And this angle is some 150 degrees. Yes, this is hydrogen bond. Okay, so there are another hydrogen bond also. I'm going to then I will put the weighting scheme on. I put ACTA to generate the shift file. I increase the cycle to 10 so that refinement converges easily, and I will define it. Now it's showing some orange like here. I have just put now C30, A32, CL2, and 605. Now it's looking reasonable. I will define it. Okay. So now shift is become 0. Things are now you can see the full is only 98.2. When I see this data here, because the data is quite a weak diffractor and it's not diffracting beyond the 42 degree. So there is merely noise. So I have to cut this data at 50 degree. So then let's see what will happen if I cut this data at 50 degree. Yes, the completeness is 99.2%. R factor is further improved to 4.46. And now the match between the F observed and calculated is very nice one. So, and I will, if you look at the refinement indicators, so there's some, all that is some very just above the threshold. It should be around 10% because it is weak diffractor. So I don't bother. And the bad reflection are not there. Some one reflection is somewhat deviating. If you omit this reflection and you are fine, it may further improve a little bit your data. Otherwise, there is no need to omit this. Yes, there is slight improvement, and refinement indicator is just okay. Okay, I am happy with this one. Now there is hydrogen bonding is of course there. So which hydrogen bonding is present? Okay, so first I will name it systematically. I'm going to select all carbon, going to name one. Okay, then I'm going to select all nitrogen. I'm going to name one, and then I'm going to select $O, and then I'm going to name one, and then I'm going to select $CL. I'm going to name one, and then next going to sort. Sorry, there is more from fix HL, and then going to sort. I'm going to refine. Now the atoms are systematically named. So now next is the hydrogen bonding. Now put IQPix off. Just I'm going to clear it. And now what is the command to show the hydrogen bond? There is command H tab. Just type H tab and press enter. So these kind of hydrogen bonding are present there. The definition is there. The distance donor separator is 2.9. So any value below 2.9, it will consider it, and the angle is 120 degree. You can change this value also, but just type H tab. I will consider 3.1 and suppose 110. Okay, then it will include some more hydrogen bond into the structure. So it depends on your choice up to which distance you want to go, up to which angle you want to go. Okay, so and then I will refine it. Then it will write all these values into the zip file. Okay, then how to display the hydrogen bonding here? So what I will do, this kind of hydrogen bonding is between O and H. So I have shown in red color. Okay, so I just select it, and there is option radius. I make it some with thicker so that it can be visible nicely. And this is okay. I'm going to select this one. This is green. Radius suppose 1.4. Now, yes, it's much thicker. Now it's very nicely visible. Yes. Now I type X tab minus G. Okay. Then it will display the hydrogen bonding here. Okay. Then you can grow in any direction. Suppose you want to grow here, just type bang, explore, and then you can see here the hydrogen bonding is there. Okay. So you can grow in any direction. This is user defined. Okay. So now these hydrogen bonds are in the table. How to make the table of these hydrogen bonds? Then just go to here. There's option work, report, and there is option HTML report. And you can of course include some image or screenshot here. Yes. Now you can see the hydrogen bonding table are included in here. This is hydrogen bond table. So this is donor N3, S3, and O4. So this is hydrogen bond, and this is the distance 2.708 angstrom with this is the standard deviation, and this is the angle. So any value greater than 120, and any value greater than less than 2.9, you can see the hydrogen bond, and this is the symmetry equivalent for the generate the hydrogen atom. So you can make a nice table. You can put this table into the Word file or PowerPoint file if you want. And okay, so that's yes, here this is the official website of the Olex tool. These are the person who are behind the developing of this software. They're the Domolo and Horace Pussman, and the Florian is actually developing the non-spherical form factors in Olex 2. And the Selexly, which are going to demonstrate just now. There are some. This is the Christian Hoopslu. This is actually the author of this program, and he's very active person, and he's updating his software, I think, almost every week or twice a week also. And if you have any queries regarding the Selexly, you can just directly write him. He will answer your queries. Okay, so next move to the demonstration of the Selexly software. I would like to answer some queries of the participants, if any. Yes, am I audible?
Yes, sir.
Yes, sir.
Okay. So if there is any query, please you can ask. Otherwise, I will move next to the demonstration of next software Selexly. Okay, so Dr. Sabil, I think there is no further queries. So
yeah, there are few questions in the chat box.
Chat box. Okay, let me check. What is that? Oh, there are so many questions. Let's first answer them. I think this one I have already answered. How to add Selexly in Olex? No, Selexly you cannot add Selexly. Selexly is different from Olex. And then, is there any basic book available related to chemical structures? Yes, there are several books available. So, which kind of structure you want? Inorganic structure, organic structure, or crystal structure? You have to specify. What is the difference and importance of anisotropic refinement and isotropic refinement? Yes, the crystal are always anisotropic in nature. In the graduate class, we generally studies the crystal are anisotropic. Anisotropic means they have different behavior in the different directions. So it is always better to refine the with anisotropic refinement. Isotropic is okay, but the anisotropic is more reliable than isotropic. So always go with the anisotropic refinement. Then Sudeep Sarkar is asking, how can I see the complete stacking of the structure using Mercury? Yes, I will demonstrate it on the following lecture when I will demonstrate the Mercury software. Then, sir, is there any book or any notes we can learn the command line defix? Yes, I already told you this Selex manual. You just type Selex 97 manual on Google. There is a nice PDF file. You can download it. No problem. Sir, could you explain the meaning of max peak and minimum peak if there is any green impact? Yes, maximum peak means the electron difference. What is the maximum density you are getting in the difference? Minimum means the hole. So electron hole and electron peaks mean maximum. Green mean you have electron density unassigned, and red mean you have over assigned the electron density. Suppose there are 2 electrons and you have assigned it as 4 electrons. That's why it's become red. And suppose there are 10 electrons and you have assigned 8 electrons, it will show the green color. Okay, so green is a positive electron density and red is a negative electron density. Then, sir, is any system why only Olex to refine is showing? Yes, because you have not put the Selex program into your Olex. So just put your Selex file into the Olex. It will show all other options along with the Olex to refine. Then Ashok Kumar SK104. I don't know what the meaning of 104.
That's no, that's the water molecule angle that time sir commented.
Okay. How to add Selexly in Olex 2? No, these are two different programs. Selexly cannot be added in Olex 2. Sir, solving in WinGX is better or Olex 2? Which do you recommend? I recommend both. I have worked on WinGX from 2008 to 2020, almost 12 years, and I'm using Olex 2 since last 4 years. So both are very nice program. I love to work on both the program. So you can work on both, or you can choose the either depending upon your choice. Sometime I could not fix the twinning structure. Could you explain? Yes, I have one complete session for the twinning structure, especially the non-mirror headed twinning. I will explain in that talk. Okay, so there is no further question. Let's move to the another interface, Selexly. Okay, so this is the Selexly. How to download? There is official site, and you can easily download. Let's demonstrate one more. Selexly, SelXLE. Sorry, Selexly. Yes. Selexly. This is the Selexly acute graphical user interface for Selexel, and there is option login. There's no need to login. Just type this word here, some 9P6. Okay. Just type this captcha and login. Now you can see there is program for Mac, there is program for Windows. So the last update was done on 15th November. Yes, just 2 days before. So you can see this person is very active. He is updating his software very frequently. You could 25th October, 23rd October, 21st October, 15th October, September 6, March 26. So he's very active to his program, and he's continuously updating his program. So now you can easily download. So this is the latest version you can download. 26 MB in size, very small software. You can just download it and you can use it. So after download, the interface will look like this, and there is option file. Just go here, open. Just open the .ins file. I put the file somewhere on desktop, and here is workshop. Where is workshop? Here it is. There is Selexly. Okay. So just I'm taking the same example. The ins file, it will open up. Otherwise, you can go for the old file. There are, I have only 2 files, HKL and ins. I will open the ins file. Okay, so this is the ins file. You can see the title, cells, let, symmetry, all the reflex, all the stuff are there. And then first step is to solve. For solution, you have to put some program. Okay, so there is option tools, not extra, yes. Add or remove external program. So from here you can remove, add the program. I have added the XT. XT is actually the Selexly. I put the Platon here. I put the squeeze option, and I put also XPrep. So I put 4 program, external program in the Selexly. You can add or just click it here, XT, then you just give the path and it will open up. So this is the from here you can address the size of the icon here. So you can put any program you want to put in the Selexly. Okay, so I have put the XT, so I just put this program XT, and their window will appear. and it will solve the structure in next few seconds to few minutes, depending upon the structure and the quality of data. Yes, now when structure solution is finished, you will see some k1.ins, k1 underscore ARES, and sometimes BC also. If there are more solution, more than one solution, then there is underscore A, underscore B, underscore C. Okay. So generally underscore A is the best one. I am going to choose this one. I will load this file and I will see the structure here. Okay. So this is the interface of select. So E. Now I can see some atoms are not good. This carbon atom is looking smaller than the other. So this should be nitrogen. I will put a nitrogen. Now you can edit from here also. So if you select any atom, it will select that atom. Okay. So RAM means you are selecting. So this atom is selected. So you select this atom, you can select this atom. This atom. So you can select here, it will automatically select it. Okay. So this is the interface of selectly. So next step is the refinement. Now there are options. You can see the Excel refine. It will refine isotropically. It will refine anisotropically. Let's first refine it isotropically. And it will run like this. And now the R factor is around some 30%. I'm just going to load the refinement results. Okay. So next step is the anisotropy refinement. Now there is Q2. This atom is deleted by mistake. So this would be nitrogen. I will select it and I change it to the nitrogen. Okay, and I will refine it. Now R factor is around some 25%. I will load the refinement result. Always you have to load the refinement results. If you don't want to, then you can discard it and you will go back to the previous step. Okay. The next step is anisotropic refinement. So there is option anis refinement. Just press this button and it will refine anisotropically. Okay. So 22% some R factor is there. Okay. So let me check it carefully. It's looking nice here. CS2 NHCO, okay. This is looking nice. Yes, I think I am missing something here. Here you can see the Q1. This peak is very higher in intensity as compared to the other one. Means I am missing some non-hydrogen atoms. So as per my structure, this should be carbonyl group. So this should be oxygen. I make it oxygen. And I will refine again anisotropically. Now the R factor is further down to some 10.4%. I will load the refinement results again. And the next step is, of course, the numbering. So you can do the numbering in two ways, either user-defined way or there is very nice option. Go to the selects and there is option automatic labeling. Just press it. It will show you some option. With residue and without residue. Since we have only one molecule, so there is no need to define the residue. Just I will auto label with residue, then it will automatically label all the. So label to 42 atoms out of 42 atoms in systematic and asymmetric unit in 2.8 seconds. So in 2.8 seconds, you are able to all the non-hydrogen atom very systematically. Now you can see the numbering is very systematic: O1, O2, N1, N2, N6, then C1 up to going to C34. Okay. So now I will refine it anisotropically. And the R factor is around 10%. I will load the refinement results. And now my next step is to fix the hydrogen. So there is option selects and there is option automatic hydrogen fix. You can use this option or you can add manually also. So first let's go with the automatic H fix and it will fix the hydrogen atom and then let's refine it. Now the R factor is around some 7%. I will load the refinement results. And now if I carefully see, then all the hydrogen atoms are there. but one hydrogen atom is missing on this amide nitrogen. So there is Q1, maximum electron density is actually here, this 5.3 electron. Now you can see this is almost double of the remaining electron density. So this is something we are missing. And so I will going to select this, or what can I do? There is another option, just select this hydrogen. There is option add NH planar hydrogen atom, non-planar or NH2 plus. But I know this is NH, not NH2 plus. I will add this one and I will refine it. Now the R factor is around 6.96%. Okay. Now I think all the hydrogen and non-hydrogen atom has been assigned. Yes. Okay. So now all the non-hydrogen has been assigned. So I will look at the formula, whether it is correct or not. There is option selects. There is some option insert. No, not this one. Okay, no, this one. Yes, update unit instruction. It will update your unit instruction. Now the carbon, hydrogen, oxygen there, and there is other option. Read unused scattering factor. Suppose you have sulfur, but this sulfur is not actually present. Then just press this one. It will remove the unnecessary atom from your formula. And now there is option weight. Okay, weight refine. This will so try to refine until converges. Okay, so there is, if you press this one, there is no need to refine over and again. It will refine automatically until the refinement is converges. So you can see it will refine over and again until your refinement will be converged. Yes, it's refining. Refinement is not still in, now after 3 runs. It's going to further next run. There is 4 runs, and it's going to the 5th run. Okay, now it's showing converge. Yes, after 5 runs. So after 5 runs, the refinement is converged. Weight are like this, and the final R factor is around 6.83. Now go to the load refinement results. It will load your results. Though how you can see the files here. Where are the file? Select actually one, and all the files are here. They have some SQL-INS file, and now you have to generate the SIF file. What you have to do, just type ECTA and refine it. It will generate the SIF file into the corresponding folder and load refinement results. Okay, so these are the steps involved when you are going to solve the file from the selectly. Yes, there are some option like suppose you want to show some polyhedra. Just select it. There is option of draw Voronoi polyhedra, and you can draw some nice polyhedra into your compounds. And there is some other option is you want to show the Voronoi polyhedra for this atom. For the asymmetric unit also there is option. If you go to view, remove Voronoi polyhedra, and if you create Voronoi polyhedra of the asymmetric unit, you can also create this polyhedra for the complete asymmetric unit also. Okay, so this is some very nice option in Selexly. I will put it off, remove only polyhedra, and there is some option of electron density map. You want to draw some 2-dimensional electron density map. Suppose you want to electron density map of these atoms. Just you have to select 3 atoms, planar 3 atoms. Press this one by typing Control on keyboard to select 3 atoms. And there is option create contour plot. You can create nice contour plots from here. And there are certain options: first atom, second atom, or center of 3 atoms. Let's take center of 3 atoms. And there is option of difference Fourier map and FMOP. You can draw any one of them. Suppose I am taking the difference Fourier map, and I'm using some step size of suppose 0.05. and I will generate the uniform counter and contours, and there's option atom in molecule contour also, and I am using suppose height is some 0.15, and I am going to say okay. So now you can draw the contour plot also like this, and if you want to show these contour in other color, there is option of nice rainbow color also, where it is plot in rainbow colors. Yes. Yeah, you can show the contour plot also. Sometimes you have to show the two-dimensional electron density. With increasing the step size and the height, you can generate the you can do some variation in the height of the contour plot also. And then there is an option remove control plot, and there is also you can also generate the suppose the I am choosing the three atoms for this time. Okay, and then again go to the contour plot and going to this for three atoms, and I'm taking the step size for one. I'm a uniform contour, and suppose I am taking height to some 0.65, and I'm going to press OK. So I'm again generate the contour like. So you can also generate the two-dimensional contour plots using these selectively. Some other important features are also that you can make a movie of your compound also. There is some option here in setting. I don't remember where it is, but you can make a movie of your compound also. Sorry, you can see here some option making movie. Sorry. Okay, I'm leaving it for now. You can check. Okay, anyway, yes. I'm just putting this control plot off, and now structure is almost final. There's nothing is left. So I will file the final file I have here. All these files are here, you can see. So selectively save it, save this form, and so it's the step involved are shown here. So there are a number of finance files which are involved in each and every steps. So this I'm going to stop here. If there are any queries from any parties.
Hello.
Hello, sir.
Hello.
Yes, sir. Good evening, sir.
Good evening.
Sir, which one is software is better? Olex software is better, sir, and Selexel is better, sir, for requirement.
Both are two different user interface. Okay.
Okay,
And both are using the Selex program for the structural solution refinement. Although Olex had its own program also. Both are very nice. I currently using all three kinds, WinGX, Selexly, and Olex 2 also. So, but if I talk about the automation, then Olex has some more. Olex and Selexly has more automation than the WinGX. But if you are comfortable with both, all the three, you can use all the three. If you are comfortable with two or one, you can do. So it's about your comfort zone. If you are stay in your comfort zone with WinGX, go for WinGX. If you ask from me, then I will say all the three programs are very nice.
It's about user compatibility.
Yes, it's about your compatibility.
Okay, sir.
From which you are comfortable.
Okay, sir.
Okay, then please next question. Meanwhile, I will read the chat box. Which do you recommend? Okay, sometime. Yes.
Sir, which kind of information one can get from contour plot?
Contour plot, electron density. There are red and green regions. So red region means there are negative electron density, and green region mean or blue region mean the positive electron density. Mean there is accumulation of electron density. And when I will explain the quantum crystallography, I will explain the two-dimensional and three-dimensional control plot in some more detail.
Oh, okay, sir.
Okay, then dear sir, SelectT and XT are the same program or different? Yes, SelectT and XT are both same program. They are not different. And then Mr. Sarvanvan R. Sorry if I pronounced wrong. My apology. Dear sir, some of my data showing space group error. Could you explain how to choose suitable space group? That can be asked only after seeing the data. And then Madhusmita Zadab, I could not find the selectively refined during refining in Olex 2. No, no, no. Selectively is different from Olex 2. Please don't mix these two different things. And Nisar Ahmed is saying, what is the use contour maze and what information provide? Yes, I already explained. It's two-dimensional electron density map. The color are representing the positive and negative electron densities. Yes, next question. Dear sir, is there any possible to extract electrostatic potential surface image from selectively? Yes, this is very actually time consuming. It needs a high computer. So if you do the electrostatic potential map, you have some supercomputer or very high speed computer. That's the problem with the present computer. With my laptop, at least I cannot generate. It is very slow. It will take several days, maybe. Yes. Okay, then there is no further question in the chat box. Let's take some other question from the participant live. Yes, if there are any question, further question from any of the participants.
Sir, during the Olex refinement, when you do the refine in the drop down box, I could not find the Selex refine. Only OLX2 refine is there.
Yes, yes. The reason is that you have not installed the Select program in your computer. Just go to.
Yes, sir, I have already installed.
Okay, then put all the files. Just look at my computer. Suppose I have Olex program installed in C drive in program file 86. There is Olex 2. Okay, this is Olex 2 1.5. So this is a folder. Copy and paste all the select file here. Then close your Olex program and restart it, and then you will see all the file in the drop down box. Okay.
Sir, I have already did all these steps, but still I could not find the.
Okay, then you go to here, home, and there is setting. Then you have to give path C Olex2/selects. Okay, then close it and then restart it. You will find the required file on the top down box.
Okay, sir. Okay, sir. Thank you.
Still on function, what you can do? You can do some more things. Just make some other folder. Suppose I make a folder named SAXI in C drive, and I put all these files here. I have put the XP here. I have put the superflip, and I have all the program here. And then I went to my Olex program, and here I put C/SAXI, and it will automatically read all the file. Okay. Is it okay?
Hello.
Hello.
If a heavy atom, not heavy atom, the water molecule is existing in the two boundary of the two unit cell, then and tell me about the 6 parameter of thermal vibration.
Yes. X minus X, Y minus Y, Z minus Z. 6 parameters are there.
And if they contributing two cells and elongated in next cell, the one of the direction.
Yes, this means the atom has vibration in one direction more than the two direction. That's why it is elongated in particular direction. This may be due to the weak data quality. It may be due to the disorder, unresolved disorder, or it may be due to twinning.